about picnic table design. The intended audience here will be do-it-yourself woodworkers, customizing woodworkers, people who are ready to buy or buyers for retail, or manufacturers of picnic tables. Question is this session really just about picnic tables? You decide. Another question, which you must answer before you can continue, is what's the difference between a philosophy major and a picnic table? If you answered a picnic table can support a family, please proceed. The approach for this session will be to discuss the alternatives, that is, the materials, dimensions, style variation, each of which impact cost, mass, tools, strength, maintenance, and durability. Also, we'll use Microsoft Excel to record the cutting list and materials to enable the automated cost and weight calculations rather than doing the math manually. And lastly, using computer-assisted design, namely Fusion 360, to automate the calculations, help to ensure the picnic table is visually appealing, show the assembled components, and enable easy parameter changes, and finally to render the design. Not included in this video session will be detailed milling, assembly, or finishing instructions, step-by-step detailed CAD modeling tutorials, hardware variations, or joinery options. There are many videos available on the internet that can do a much better job than this video will to answer those questions. This is not a 12-step plan, it's a 5-step plan. But first, we must admit we are powerless without working, that our lives are, well, you complete that sentence. The 5 steps are: step 1, find an existing plan. Why start with a blank sheet of paper when you can find one that's close to what you need? Tailor that plan. Tailor the style, dimensions, materials, appearances, cost and weights to adapt to your individual preferences. Model that plan. Draw the components, position them, preview the results, render that, generate the customized plan, drawings, cutting lists, weight, cost estimates, and so forth. Step 5 we will not actually cover, which is to do the actual build of the picnic table itself. Again, that can be found in many places on the internet, detailed steps on how to actually build the thing. Step 1 will be initially to establish the criteria that we're looking for. In this case, we want a round or an octagonal picnic table. We want one that's suitable for outdoor use with minimal maintenance, costs less than $400, weighs less than 200 pounds, seats 8, and most importantly, small enough to get out of the basement or out of a garage door. There are a number of sources. Some of my favorite sources are Pinterest, YouTube, and a White. Here are a couple of good ones. If you also need the complete instructions on how to build, mill, construct, assemble, paint, stain, whatever you want to do. This one from Woodworkers Guild of America for a round tabletop. Here's another octagonal one, hard for me to say, from Woodcraft by Bill Sands. Most existing plans will start with a minimal cut list, which is the name of each component, the quantity, the thickness, width, and length, and that's about it. And this, we want to tailor more than just that, so we're going to add a few things to this. In addition to that minimal information provided via existing plans, we're going to add some things, namely the board feet, the cost, the mass or the weight, and what variety of wood we intend to use. To calculate cost and weight or mass, we need to know how many board feet do we have. So here's a calculator that you can use, which is on the internet. You enter your values: 1 inch thick, 12 inches wide, 1 foot long, one piece. Calculate that. Comes up with 1 board foot, obviously, because 1 inch by 12 inches, 1 inch thick, is 1. We will take that board feet and then use it in our other table to calculate the cost and the weight. So here's a table for various species of wood, the mass and the cost per board foot that we'll use to construct this picnic table. This table will be used along with the formula in this to vary the wood species and come up with what we want to meet our criteria, which we said was, I think, $400 and 250 pounds, something like that. So obviously, if we use African teak, we've exceeded 250 pounds. We've also way over exceeded our cost. So let's try a couple of different things. Let's try, let's say, for example, cypress. And when I change that, you're going to see all these calculations over here change. Well, that's within our criteria. Let's try another one, maybe redwood. Okay, but the cost has gone beyond our criteria. So let's try one more here. How about western cedar? That almost does it, but not quite. It actually has exceeded our $400 budget. So maybe we can make some course corrections here. Instead of using a board thickness of 1 1/4, what if we change that to 1 1/8 and see if that, okay, it does. Reduces our cost under $400, so looks like Western red cedar will meet our criteria for building this picnic table. The formula for calculating these are here in this Excel spreadsheet. If you just insist on doing the math yourself, here's an example, pretty simple. Calculate the board feet, which is thickness times length times width times quantity. All must be in inches in this case, divide by 144. And then we take that board feet, multiply it by the cost per board foot, get the overall cost. If we want the weight, we can again take the board feet, multiply it by the pounds per board feet, and come up with the mass total. So far we've done step 1, which was to find an existing plan. We actually found 2 that meets our criteria, and then we've tailored it. The 2 that we used, the round table from Woodworkers Guild of America and the octagonal from Woodcraft or Bill Sands, and then we plugged the values into our spreadsheet, came up with a cost and a weight that meets our criteria. Here is a rendering of an octagonal picnic table. Well, that's tough for me to say. That looks like it does seat 8, so that fits our criteria. And here's the round one. It looks like it also seats 8 folks. So we're going to take a look at what other things we can do here in the model. We've settled on this round picnic table, which, as you can see, is comprised of 3 components: the top, the base, and the seats. Those are actually all separate models themselves. In fact, the top itself can be switched out from this one to that one because those are external. Looking at the base then is also subdivided into a hierarchy of components: the legs, left, front, so forth, the braces, which we can also turn off and on, as well as the stretchers themselves. So if we just want to focus on one thing, there are the stretchers that go each way. Turn those off. Look at the legs, for example, only. There we see those with the cross stretcher. Helps to organize the model a little bit and makes it simpler to change things. Also then, within each model, let me turn all these back on. So when I'm looking at the base, we enter in here the same parameters that we saw in our cut list. So they're entered in here. The model then will use those. So for example, if I decide that, gosh, I don't want the stretcher width to be 5, but I want it to be, I don't know, 5 1/4, something like that, can make that change. The model will be updated with that. The model is also displaying the color-coded version of this model. Things that are the same color, for example, this board of the tabletop and this one are the same. You can tell that because they're the same color. Likewise, these two middle ones, likewise on the seat, the inside and outside boards are the same. Just gives us a clue that we only have to cut those once. Sorry, I meant to click this one and this one are the same. The inside one's not quite the same color because it has that arc in the middle. The weight or mass that we calculated here before in our cut list does not include the effect of milling, in other words, cutting the boards down to size, or any hardware, whereas the mass shown here in the model does take into account the fact that we've trimmed these boards from what the original size was down to some shape like that. It will also add in whatever hardware we sketch into the model. Also, mass or weight is not a constant. If you have a wet board that you just brought home from the lumber company and compare it to one from a 100-year-old barn find that you've got, they're not going to weigh the same. Likewise, if you're building this on the moon or in orbit, your weight can change. The model has been rendered here in 3D, which we can focus in on. As we've seen, as I eliminated, we can rotate it around, we can explode it, everything you might want to do in 3D, but it's also useful to switch sometimes to 2D model, such as this very simple 2D model here, which is handy if you're going to hand it off to someone to actually build this for you. You can also take this and export it to a PDF format. So here's the same thing, same 2D drawing, this time shown in Adobe PDF format. Makes it handy if you want to email it to someone who doesn't necessarily have a CAD modeling program. Easy to share, but easy to read. Might also be handy for someone who doesn't necessarily use Fusion 360 but would like to comment on your design before you start building it. You can do that by viewing the details on the web. So here it is shown on the web. This is a feature of Fusion 360 that allows you to collaborate with others who don't necessarily are not necessarily allowed to do the model, but may want to take a look at it and make comments on how to improve it for you. Some sort of feedback along those lines would be very handy. Don't necessarily know how to, they may not necessarily own Fusion 360 or know how to do modeling, but may have some really good design comments that could come in handy. So to wrap up this session, we did several things. We found a plan that was similar to what we wanted. We tailored that plan to meet our preferences. Modeled it in computer assisted design, namely Fusion 360. Did some renderings in 2D, published it in a PDF, the 2D model that is, and also out to the web. Wouldn't it be nice if instead of having to go through all of this, that we could just sign on someplace, specify that we want a round table, how big, made out of cedar, cypress, whatever, not to exceed $400, and so on and so forth, and have it spit out some designs that meet that criteria. We pick one, send off, put it in our cart, order it, and it's on our way. That would take some kind of CNCing and 3D printing capabilities that are beyond my skill level for sure. So if you would indicate what sessions might be useful to follow on this. I haven't gone into the details of how to do this exactly in Fusion 360. That might be useful. Let me know what else. Your constructive comments are always welcome. Please like and subscribe or not. And thanks for watching. Can't say watching. It's been a picnic, but without the beer and the hot dogs. Thanks again for watching. See you later.